Okay, so welcome to today's lecture. This is going to be a series of lectures where we're going to implement a semi-sophisticated program. And this program is going to do something that one of the other professors in the department called lazy literature. So this is an assignment by Dan Zingaro. He's a couple doors down from me in Deerfield Hall. The question is kind of long, so I sort of broke it up into slides. So let's just take a look. So the goal of today's lecture is going to be to write a program that's going to consume pieces of literature, like Alice in Wonderland. We also have Lord of the Rings and other pieces of literature. I was trying to find the comprehensive corpus of Dr. Seuss, but that's actually hard to find. So if any of you can collect all of Dr. Seuss, I think it would be cool to have like that as one of our test cases, to generate Dr. Seuss sounding text. Right. So we want to consume a text, and then we want to generate text that reads like the text that we have consumed. So it's going to be gibberish English, but it's going to be good sounding gibberish, like pseudo gibberish, right? It's semi-random gibberish. So our plan is going to be to break this problem into two phases, a learning phase and a generation phase. So in our learn phase, we're going to have to consume the text somehow from files and then store information. We're going to store the information in dictionaries for reasons that we'll get to. In the second phase, we're going to want to generate new text using our stored information. So again, what we're going to generate is going to be gibberish, but structured gibberish. And write two versions over 2 lectures. Oh, right, so today we're going to write a version 1, and then tomorrow we're going to write a version 2.0, which is better, right? So today I just want to get basically anything working. Like, do you know how someone can speak gibberish, but it's like Italian gibberish or like French gibberish, like cinéma, le plus. Yeah, that's gibberish, right? But it's like you can identify that as like French. I shouldn't do this with French speakers in the classroom. This plays a lot better in Australia. Right? That's Italian gibberish, right? So well, but that's not gibberish, right? So right, that's basically like what the generation of our text is going to be like. It's like, oh, I can identify that as like almost Tolkien, but it's not quite Tolkien. So we're not given any extra information. Like you guys are gonna have to get used to solving problems. Like they're not gonna go to Google and they're not gonna give you a task like, oh, can you convert this while loop into a for loop? Like they're gonna give you like real world questions to solve using computer science. So suppose like we're consuming this text, right? So we have a very short book that's comprised of 3 lines. Dan played ball, Dan walked fast, and Dan said so. What is our strategy going to be? Like, what are the important pieces of information in this text? Like, so far, we have not been told how to consume or how to generate. Right? So part of today's lecture has to be a discussion of what our strategy is going to be. So does anyone have any ideas? This is very open-ended. Yeah. How long each sentence is and how sentences vary in length? 3, 3, 3. You want to generate a new text where all the sentences are the same length?
If the original text also follows that pattern where every sentence will be length, so that generated text have to follow a similar
pattern? That's one way of looking at it. Yeah, we could use sentence length as one marker, sure. But I think like that's already one step too far, right? Because like you're talking about the length of the sentences. Like, how do we even generate the component words of the sentences? Like, we should start there. Like, so you're saying all the sentences here should be length 3. Okay, so, but like, what should the first word of the first sentence be? Yeah. Why? Okay, like, these are all correct answers. But you have to, like, refine your thinking to say more precise, useful statements. I just speak English. I never learned it. Right? I'm not joking. We'd have to ask the English as a second language people about grammar, because did anyone here learn English as a second language? Yeah, you guys probably know grammar better than I know grammar. I've never been taught grammar, right? So we want to somehow remember that Dan was first, and then played was second, and walk was second, and said was second. Like first what? First in that sentence? Like first in the first sentence, or first in all sentences? Okay, so what I'm hearing you say is that we're going to have to remember context somehow. Like the context that the word is in is important. Like you're telling me that Dan is important because it happens to be the first word in each sentence. Its context means that there's no word to the left of it, really. Right. So following that line of reasoning, I think the important thing to remember here is, given a word, what words follow that word in the text? Right? So if I generated a new sentence from like these three sentences, and my new sentence started Dan, you'd be okay with that. And maybe Dan walked, you'd be okay with that. But maybe you wouldn't be okay with Dan fast, right? Because there's no instance of Dan like being connected to fast. And remember, our text is going to be like hundreds of pages of text. Right? This is just a sort of basic example so we can talk about it. So how I think would be a good way to store the context here is using dictionaries, right? So figuring out what information we want is important, but it is also important to figure out how to codify that information, right? There's many ways that we could do it. We could store frequencies, we could use lists, we can like use strings. So this is why you guys are going to have to take a whole course in data structures, right? Depending on the data structure you pick, a problem can become very easy to solve just by first figuring out how to represent it. So I think we should develop some type of dictionary that can do this, right? It says, okay, the words that follow the word Dan are played, walk, and fast, right? The words that follow played were ball, and so on. So then we can do something like, okay, start with Dan, then pick any word that comes after Dan, randomly, like walked. And then pick any word that comes after walked, randomly. So in this case, fast. So we would generate randomly a sentence like Dan walked fast. Now, that's one of the sentences that are written, but we don't have a very large sample space, right? So you shouldn't be surprised that we can only generate 1 or 3 sentences, given that we've learned so little. But you can imagine now we're given sort of full sentences, right? So the data structure is going to get quite big. And this is the full data structure. And this is the first process that I want to write today. Something that's able to take a sentence, right? So remember that we're going to read a file. And the file information is given to us line by line, right? So here, this could be one line of the text file, one sentence. And we have to codify it into this dictionary in this precise way. Now, we missed a few things on the last slide. For instance, it is the case, was this the class where we had the big discussion about empty strings? I think it was, because someone came and saw me. Did follows the empty string, right, technically, right? Because that's how we're going to denote it as like the first word. Otherwise, if I didn't allow the empty stuff to follow the empty string, Dan would have never, nothing would produce Dan. So in any case, we have the empty string, and what follows the empty string is did, right? So in this case, the empty string we're interpreting as the beginning of a sentence. So the empty string comes before, or what's the word for comes before? Precedes, yeah, precedes did precedes you precedes get precedes the precedes 3 different types of words, sword, old, and waterfall. And then we can just go on through the rest. Now, is waterfall in here as a key? No, that's one problem that we're going to have to figure out, right? Because waterfall comes at the end of a sentence, right? So things that come at the end of the sentence are never going to get keyed, right? So we're going to have to fix this in our version 2.0. Also, what should we do with punctuation? Should we keep it or should we drop it? Like, should we keep waterfall with a question mark, or should we just process waterfall? Right? But then we have to worry about how do we end our sentences. Right? So I was actually really thinking about how to solve this problem last night. It's not, working with text is not that easy. Even what you were saying about pulling out the noun, like pulling out the grammatical information, is very difficult. That would be very helpful. I think that would be the most powerful type of text generation that we could do. If we could come up with some type of probabilistic model which generates a noun and then the most probable thing that comes after a noun. Like, we could technically form real sentences, but again, we're generating gibberish. Gibberish plus the grammatical information would give us sentences. Okay, so why don't we try to write a piece of code that can read one line and generate this dictionary, and then we're going to take that and expand it to be able to take in whole text files. Right, because this is a good place to start. Oh, okay, so this is what I want to implement today. So today I want to implement two things. Make dictionary, which takes a file pointer and returns a dictionary whose keys are strings. Is that how we define a dictionary? Okay, we're going to return a dictionary whose keys are strings and whose values are list of strings. So the key is going to be a word, and the value is going to be all words that succeed that word in any of the sentences. So I'm going to go here. I'm going to, what day is it? Monday. That sucks. Oh no. Okay, you can see, right? Okay. Right, so let's write something. Okay, let's just call this one line. We'll process one line. We're going to take in maybe characters, which is a string, and we're going to return a dictionary, which takes, what, strings to list of strings, and I have to call in typing. From typing, import list and dictionary. Okay, so we want to take in, what do we want to take in? We want to take in something like this. And then we want to return the dictionary. I don't know, so I'll just predict one thing in the dictionary. Did, should have, be followed by you, right? And then the rest should come. Okay, so any ideas how we do this? So I guess the first thing I should do is to start a dictionary. There's an empty dictionary. And then at the end, we'll return it. What should I do? What do I want to loop through? Okay, so let's think about this, right? What is it we want to do? Like, at a very high level, right? Without even worrying about the processing. Like, in the bare minimum, we're going to have to walk the words of this line. Yeah? So why don't we first figure out how to walk the words of the line before figuring out how to do anything else, right? So how can I get the words of a line? Yeah. No. Okay, well, tell me the for loop that will generate me the words of the line. The for loop we're going to use to actually, like, process each word of the line. But how do I get the words of the line in the first place? Up back there, yeah. You guys. Yes. I actually think split is enough. Yeah. But one word about this, it's not going to kick out punctuation. Okay, so it is enough to take in C's and to split it, right? This is going to convert the input. What happens if we try to split something which is unsplittable? Okay, perfect. Okay, what happens if we try to split something that's empty? Okay, that still works. Okay, so we split something, and I want to walk through this. So for a word in here, maybe I'll call this sentence. Sentence. What do we want to do now? Yes. Yes. So we want to key that. I want to do something like this: h of word, append the next word. But remember, I can't key into a dictionary if the key doesn't exist. Right? This will give me an error. So we have to do something like this. If word in h, do something else. I have to create a new value here. Okay. H at word dot append. Okay, but here's the problem. I have to append the next thing, right? So I only have the current word, right? So I'm going to need some type of counter so I can say, give me the thing that comes after this word, yeah? How can I get a counter? Should I do it with a while loop or can I use enumerate? Because I can do something like this, like give me a counter in here, right? So maybe now that we're more familiar with Python, you can appreciate why I use enumerate, right? So I can always say for x in x's, print x, right? But I shouldn't use numbers. Mondays. So for x in x's, print x, okay? But I'm also telling you that I want a counter. So to get a counter, I can always say I is equal to 0 and then increment in there. But since walking through a set and wanting to know its index is so common, that's why we're given this enumerate function. Right? It's just telling me, it's just counting for me, right? This enumerate, right? So I'm just going to say, do you want me to write this as a while loop instead? I feel bad. Okay, so I think this is the best way to do it. But otherwise, maybe when I upload this to the website, I'll like do both versions. Maybe I should do that from now on, like put a version which is like the most pure. Okay, so what do I want to do? I want to append the next word in the sentence, right? Which is what? K? Am I doing something wrong? K plus 1. You are correct. Exactly. That's the next thing I was going to ask. So what's the problem now? Yeah. You guys see that I'm getting an index 0 here, right? As soon as I have an index k and I'm calling k plus 1. Like indexing with k is already dangerous. So I need to avoid walking off the very last member of the sentence. So how can I do that? Elegantly. Any ideas?
Would we check that k is not equal to length minus 1?
Yeah, I could do that, but I wanted something elegant. Okay, so, and what else do I need? That k is less than... Oh yeah, I don't want to overcomplicate this. So if word is in h and k plus 1 is less than the length of, what, sentence? This is not very good code today. And elif this. Sentence. Okay, let's give it a try. Whoops, that shouldn't be there. Okay, let's just grab this piece of text. Hopefully it's not going to screw up. Okay, asking too much. How about this? What is happening? Ah, there is a new line. Okay, so there's our sentence. Let's give it to one line. And we got an empty dictionary, which is exactly what we wanted. This should be a less than, and this should be a less than. See? But professor, I only made one mistake. Ah, I know what's happened. There we go. That should fix it. Right, because I only had the sentence split in one place, and then I was using it in multiple places. So I should just like change sentence into the structure that I want to. Yeah. Okay. That's better, but we're still missing something. We're missing the empty space. Empty space did. So like the other sections are like are denoting the fact that did starts a sentence. So do you guys want to I don't know there is no correct answer. It's like what strategy do you want? When we generate new sentences, do you think that we should only begin sentences with words that began sentences from the text? Or not? Right? No, because I'm checking I'm saying I need to check the next, I have a word, and I need to pair it with the word that comes after it. So I need to stop at the second last word, not the last word, because the last word has no comparison. So, okay, maybe we should in our dictionary just add this key, empty and the first word of the sentence. What? That should work, no? Okay, so now I have that. Okay, so that's one line. So let's look at the pieces of text that I have here. We have Alice in Wonderland. We have Lord of the Rings 1, Lord of the Rings 2, and Lord of the Rings 3. Okay, so we're definitely going to generate some Tolkien-ish type of language. But please, if any of you have time, please get me the Corpus of Dr Seuss. I think Dr Seuss would be the most fun to generate. But I think the reason these ones were picked, do you guys know what the public domain is? Yeah, these are in the public domain. I think after like 50 years, like anything that you own copyright on is supposed to become free.
Yeah.
But like functionally, we don't have this anymore. Because then everything Disney did would have to be free at this point. Okay, so should we start with Alice then, I guess? We'll start with Alice. Okay, so here's the thing for one line. So let's now expand this to one book, right? So a book should take a file pointer. I think that's called text.io, right? Like this. And it should return this type of dictionary. We're probably going to have to scrap our one-line code, but it's okay. Does what one line does, but for whole book. Okay, so let's deal with this one now. So here's our starting dictionary. We're going to return that. So FP is now a file pointer. So when I say for a line in, I don't want to use L, for a sentence in this file pointer, that's going to pull out one line, right? Okay, now I have a sentence, which means I can just take this code, right, and do this. And that's all it took, right? So we already wrote a function which worked on one sentence. And now I'm saying, okay, pull out a sentence and just do the thing that we did on one sentence. Like I'm trying to show you how I program. I'm trying to program something small, right? Getting something small to work, and then increasing what that something small can do, right? I would never have started with the whole file. Maybe some of you would have tried, this is called the Big Bang approach, and it never works. Try to do the smallest thing correctly that you can, and then add, right? And it will make your functions more and more robust. Yes? Oh, yes, sorry. Return H. Okay, let's see if this works. It's going to give us a lot bigger dictionary this time. So, what's the right thing? Is it not text.io?
Oh, you forgot to import it.
I forgot to import it. Thank you. Okay, how do I open a file? File pointer is equal to fopen. Do I get autocomplete here? Huh? F dot open like this?
No, or is it just open?
How do I open a file? Anyone? Isn't it F open?
It's just open.
There's 10,000 computers in this room. So what was my text file called? Alice.txt. Okay, Alice.txt for reading, right? Okay, let's try giving this to one book.
What?
Oh, I can't do... This is killing the dictionary every time. Yeah. Okay, so let's deal with that later. Well, at least that kind of looks... So there should be a lot of stuff that follows the, right? Okay. Okay, so it is at least the case that we've read in... Like, we have the data structure that we want-ish. I just really would now like to add in this empty string for commencing the sentence. So this I want to do. I know how I can do this. Okay, so H at empty gets appended this. And then I'm just going to put in as an initial thing in my dictionary empty. Right? I know for sure that's going to fill, right? Unless the book is empty. So this should fix everything. Okay, so let me get out of here. Go back in. Get this. Oh no! Who has an old style Mac? Anyone? How much time do we got left?
15 minutes.
I'm going to just do this until this dies, right? And then we'll just continue tomorrow. Or I can write some stuff on the board. Sorry, guys, that's my bad. Or alternatively, I can kill the recording, and that may get me some extra juice.
Sure.
Okay, how about I'm going to kill my Wi-Fi. I don't want to lose the recording. Okay, so what was I doing? FP, one book. Let's read in this one book, set that equal to H. Whoops. What? List index out of range. Let's just print these sentences and see what's happening. It's reading in empty sentences. That's a problem. Okay, so we're gonna have to. Okay, well I'm gonna type this in for tomorrow, right? Or not tomorrow. When's the next time I see you? Wednesday? Okay, 2.0 issues, right? Books may contain empty lines. How can I check for an empty sentence? I can always write something like if sentence, if not sentence, if the sentence is empty. Do you guys know this? No. Okay, so for now we'll forget about the fact that we don't have leading sentences, which is crappy, because how do we choose now where we should start? Okay, in any case, so we don't need this one line anymore. I'm just going to get rid of that. How about we generate one line? And what do I need to give it? I need to give this a dictionary of this information, correct? And this should return a string. Okay. So let's generate one line of text that's maybe of length n. All right, so for k in range n. Yes. You have a power adapter. Yes. Bring it down. Come on down. Thank you. You are indeed a hero. $1, Bob. I think I just broke your adapter. We are good to go. Boom. Thank you. Okay. How can I generate one line of text? Like, what's a good strategy here, right? So, it's like I have this dictionary here of keys, right? So here are all the available words to us, right? So I can say something like, geez, let's pick a random key. Okay, let's choose the as the first word in our sentence. So we have the. So then what follows the in this book? All of these things. So how long is this? Length of this. Is there Python random element from list? Right, I turned that off. Can anyone find out if I can get a import random? Rand int 10 gives me what? Do I have to do this longer? I'll get there. Random.randint. How do I get a random integer? 0 to 10? Okay, great. Okay, so I want to, okay, so if the first word is the second word I want to pick should be a random word from this list. So I really want to write a function that just picks a random word from a list. Now it's going to make my life a lot easier. Definition, random word. It just takes in x's, which is a list of strings, and should return a string. So what should we do here? I need the length of x. And then I want to return I need to import random, right? Import random. I want to return random.randint 0 to the length, 0 to n. And then I want to return the element that's indexed there. Yes? Is there a random.choice? I'd have loved to use that one. Why didn't you tell me 5 seconds ago? Anyways, I'm going to use my random word function that I just wrote. Oops. What's wrong? Oh, I need to give this a name. H. Indentation. Oh, I didn't actually finish this. Okay, so I have to open something. I have to give it to my one book. So I have H. My first word is going to be the. So I'm just going to say sentence is equal to the. Then what's the next word of my sentence? I want to take H at the, And then I want to pick a random word from here. This is, oh no, that should be right. Work, please. Okay, so the matter with, it's going to be you, I know it. Okay. The matter with its right size to the caterpillar. Yeah. Okay, so I have generated a gibberish Alice in Wonderland sounding sentence, right? The matter with its right size to the caterpillar. It's gibberish, but it sounds like something Lewis Carroll could have written. Okay, so, jeez, I can't post most of this. So, okay, why don't you guys just think about version 2 for next time, okay? So, I didn't quite get there today because what I would have liked to be able to do is finish writing this get one line. But that's just going to be the same procedure that I had just sort of did in the console. So, on Wednesday, I want to write a version which is going to generate less gibberishy sounding stuff. So I want you to think, how can we use probability to solve these questions? How can we use more context, right? And think, someone has to have a good idea out there how we can generate better words than the other class. So see you Wednesday, guys.